Welcome back, friends and colleagues. Thanks again for being here. And Department of Industry, Science and Resources, CSIRO, our platinum sponsors, we're really grateful. Two great friends of ATSE and, of course, two critical agencies to the capability of Australian science and technology and all of the industries that we enable and innovate. Our third panel today addresses manufacturing for the 21st century, how Australian manufacturing is evolving to meet the demands of a rapidly changing world. And I'm delighted to introduce our moderator, Professor Bronwyn Fox. She's CSIRO's Chief Scientist, and she's known globally as a leader in advanced manufacturing, materials science, and Industry 4.0. She's passionate about bringing together multidisciplinary teams for collaborative research, which flows nicely from our panel discussions earlier this morning. Bronwyn was formerly the Deputy Vice-Chancellor Research and Enterprise at Swinburne University of Technology, and she's a founding director of Swinburne's Manufacturing Futures Research Institute. She's also an incredibly well-regarded global collaborator. Bronwyn has been an ATSE Fellow since 2017. Please make her welcome.
For that really warm introduction. It's such a pleasure to be here today and to be with these amazing other panellists who I'll introduce to you in just a second. I'd first like to acknowledge that we are meeting today on Ngunnawal country and to pay my respects to the traditional owners of the land and their customs and traditions, and just to acknowledge that we have so much to learn from Australia's first scientists, and it's so important that we continue the work we're doing in having conversations about how we can walk together to a better future. Manufacturing for the 21st century. Manufacturing has changed enormously in the past 2 decades since I started working in manufacturing. And we are at a really exciting time with so many opportunities to capture for Australia. Manufacturing is now more of a capability than it is a sector, and it impacts everything that we do, from medical science to defence, to energy. It will impact everything that we do. And it's just a wonderful capability. And I was really delighted to hear Jane McMaster talk earlier today about systems thinking, because I really do believe that that is one of Australia's unique advantages, whether it's because we're geographically isolated and don't have the same degree of specialisation as other countries, whether it's because we just naturally think in a problem-solving mindset. It is an incredible advantage for us as a nation, and it's really seen as something distinct and different that Australian manufacturing brings to the table. I'm inspired every day by things that I see in industry, and just last week I had the opportunity to visit a company called QuickStep, who are based in Sydney and in Geelong and in Melbourne, and I've actually been working with them for about 20 years. They were originally supported by CSIRO as a startup about 25 years ago. They've recruited some incredible people who are focused on advanced technology, automation and digitalisation and robotics. And I had the chance to see through their drone manufacturing facility in Geelong, and to hear from Luke Preston, who's their head of technology, who was just phenomenal. Luke spent 5 years at Tesla in the US as it was ramping up some of their major Model 3 manufacturing facilities, where they were really pushing the boundaries of using robotics and automation. And I was just so delighted that, you know, Luke, a Geelong guy who'd started his career at Ford, had that international experience, has come home to bring that to bear to an Australian manufacturing company. So I think there's so many exciting things and so much we can talk about today. So I'd love to welcome our panellists to the stage. So if I can welcome them, I believe we're going to have a slide with your names in order. And I will apologise, we do have a slight split in the panel today so that you can see the slides, because some of them have slides, and so that we don't have the projector light in someone's eyes. So can I welcome all the panellists to the stage? I would now, oh great, great, I have a friend, this is wonderful. First of all, congratulations on becoming a Fellow of the Academy. I really encourage you to embrace the Academy and to take every opportunity that you can to contribute. It's a wonderful fellowship that you've joined. You're amongst friends today, fellow engineers, scientists, technology enthusiasts, and one of the great things that I've really benefited from is being part of this incredible community of people who are really committed to doing good and using science and technology for good in the world, and to have the opportunity to work with so many people in this room who I've admired for so long, and to seek their counsel and mentorship. So thank you to the ATSE community. I will now pass to you, Baohua, to introduce yourself, and then we'll work our way down the panel.
Thank you, Bronwyn. Good morning, everyone. My name is Baohua Jia. I'm a professor in RMIT University. So I'm a physicist working in photonics field. So photonics is basically the science of light. So talking about photonics, it's really emerging, but really making lots of impact in our daily life. So photonics has lots of applications in renewable energy. So making our internet faster, and also having these photonic chips, so talking about computing and also communication as well. So I'm extremely lucky to work in this field. So as like the enabler, light is basically the enabler of life, and also I think by the end of the day, when all the other energy format is going to be depleted, so solar energy is still going to be our long-lasting energy. So that's come with light. So I just feel that using light, we can do a lot of things. So using light to manufacture very tiny structures. So really feel excited about the field, and yeah, it's really great to be part of ATSE. Thank you.
Thank you. Stephen.
Well, Stephen Foster, I'm the Dean of Engineering at UNSW for the moment. My background is a structural engineer. My expertise is in bringing new materials, particularly cementitious products, higher performance steels, higher performance concretes and the like, into reality through standards and the like. And I think I've got a few slides and I'll talk to those later. Thanks.
They're behind you now.
Oh, they're behind me now. Okay, in that case. Perhaps we just go to the next slide. I just wanted to think here and just go back. Kodak had 100 years for the development of film technologies from 1892 to about 1990. Technology eventually took them over. Nokia had 10 years till technology took them over. The iPhone's been with us for 15 odd years. When I look back, and I won't look behind me, so I'll put this in front of me. When I look back to you know, where we were, you know, in the 1960s, we were known as the country that lived off the sheep's back. Wool and wheat were our biggest two exportable commodities. We developed some manufacturing capabilities. They're all gone. Automotive, clothing, footwear, petroleum, we only have a minimum area in that area. Cement, clinker, very largely moving offshore through imported steels and the like. And you look at that graph behind us, it represented about an equal weight, 20% of our export market. Go forward to a few years ago, and that has more than halved, down to 8% of our export market, and our resources industry has doubled over that time. So we're looking at the topic today of modern manufacturing, and what does that mean? If we go to the next slide. How many people recognise these schemes? How many can tell me how many are still current or open? I guess one question I have here is about our short-termism in the way that our governments operate, our politics operates. If we bring up the next slide, please. There we are. Not many. In fact, the only one is the launch of Australia's Economic Accelerator. I took this to my head of school of mechanical engineering and asked him the question, not this one, was the last one. Said, well, there's this big announcement, what impact is that going to have us on the faculty? He said, Steve, well, we'll wait and see what's different about this announcement to that of the last one. So I think we've got to move, we've got the capabilities of moving, but I question, can we do it? And if I go to the last slide, this was a reorganisation of a question that I asked my Deputy Dean of Research, Innovation and Industry to comprise. Here's a question, why Australia doesn't commercialise more stuff and our strategy behind it. And I simply moved one word of that and say, why doesn't Australia commercialise more stuff, and how do we do it? So I'm happy to talk to that.
Thank you. We'll continue with our introductory remarks, and Yun, over to you.
Hello everyone, my name is Yun Liu from IU. I'm a materials chemist, my work actually is try to find out how the atoms are arranged and structured in a specific ways to that in those materials for unique new properties and new functionalities. So once we understand that, we are in a better position to invent materials for cutting-edge technology and innovative industry. So for example, my discovery of the dielectric materials has already triggered the new generation the capacitors development and manufacturing. And the capacitors actually, you may know, these are very essential device, components for all electronic devices. 500, 800 capacitors in your mobile phone. That not only determine the performance, but also determine your lifetime of your mobile. So my invention on the catalyst designs, and I can provide the opportunity to purify the PFOS, for example, PFOS contaminated waters, and to improve our quality of life. And also that catalyst can provide the opportunity to solve the critical issues for large-scale hydrogen storage and long-distance transport. So that will be very, very good and support to future Australian hydrogen industry and hydrogen economies. I believe in 21st century, Australian manufacturer should move towards invention intensive, high value added, and sustainable models. I'm so glad I have this very good opportunity to lend my experts and voice to ATSE. And I believe working with other fellows together in the future will elevate the Australia high innovative technologies and also the innovative the manufacturing in the future for Australia as well. Thank you.
Thank you. Chamindie.
Good morning. Hi. My name is Chamindie Punyadeera. I am a professor from Griffith University in Queensland, the sunshine state of Australia. And when you come from Queensland and you come to Canberra, you really feel the cold. I'm an innovator and a translational researcher, and also a strong advocate for women in STEM, especially for those women from culturally and linguistically diverse background. I'm the odd one in academia. I moved from industry into academia. I used to work at Philips Electronics in Netherlands, where I was developing point-of-care devices and commercializing. So when we moved to Australia, I had the biggest issue because my KPIs from industry into academia did not marry. And having no publications, because academia mantra is publish or perish, right? And I struggled a lot. Because of my ability to work with industry, I think really kept me going, because I went to NHMRC, I think 8, 9 times to get funded, and only during the pandemic, I was very lucky to get twice NHMRC funding, and the work that we do is use of non-invasive diagnostics, development of next generation of diagnostics, and that's simply using saliva, and you heard it right, saliva. And during the pandemic, we saw that we needed to have these field testing, home testing to stop the spread of virus. And I think it's the, how would I state it, it's the moment where saliva technologies gain the momentum. And now I'm being asked to use saliva for Parkinson's disease, Alzheimer's disease. And we in Australia, I think we have a great opportunity to work with industry and with the government And I'm really happy that I got the ATSE fellowship, because it's like I was telling my mentors the other day, it's like giving me the microphone. Now I can speak louder. Thank you.
And good morning, everyone. My name is Tuan Ngo. I'm professor in civil engineering at the University of Melbourne. And also at the moment is the research program leader of the new CRC Building 4.0, which is a CRC dedicated in transforming the building and construction industry. My passion is always about how we can design buildings and infrastructure to be more resilient, more adaptable, more affordable, but also have to be very safe, because we are dealing with a lot of extreme events. It can be natural disaster like bushfire, flood, earthquake, but also can be technical man-made disaster. So in the early part of my career, I worked a lot in defense. So I was involved in the DMTC, which is the Defense Material and Technology Center. So I spent a lot of time working with our defense manufacturer like Thales Group. We work on developing a composite material for blast and ballistic protection. Those material can be used in Bushmaster or Hawkeye. So I learned a lot from how advanced manufacturing can be done in defense. And later on, I moved on to work on the building and construction. So my passion is about how we can build faster, cheaper, and offsite construction. You probably heard about modular prefabricated. I was part of the journey, setting up the big industry body called Prefabos. I'm currently in the board of the director. So we have seen a lot of growth in advanced manufacturing in construction. And I can see this is the key. If we want to solve the housing crisis, we need technology. And advanced manufacturing is really one of the key we can transform our construction industry. Thank you.
Thank you so much. We have a short amount of time to discuss a few questions, and then I'm really keen to hear from the audience about what they would love to know about your own research and how you've come to this place today. Yun, I'd like to go to you first. What, in your view, what are the key advantages that you think Australia has in manufacturing, and what are the opportunities that we could be harnessing? And I note that we had a really interesting conversation, as always happens at these events in the ladies' toilets, earlier about translation and how you're thinking about scaling. So you might like to draw on that.
Yeah, thanks, Brenna. And so I think this like Australian. Actually, like a couple months ago, I have attended an international conference hosted in Australia. And I heard a few people and told me, actually, you are so lucky because the politician in Australia listen to the voice from scientists. I think Australia already, they have a very good systems, and they build, we already established like a national priority area, and also put the investment on that. I think really actually is like some kind of the communication between the academia sectors and the industries together, and combined with the government, the policy drivings. But I think something is missing, actually from lab, research outcomes, and to the large scale industry. It's a lot of the technical issues need to solve. That would be great, and if government to consider the investment in that part, form not this R&D chain. We're always talking about industry chain, but actually R&D chain is very critical to make us possible to moving faster. But regarding my research, I think hydrogen energy is definitely will come in very soon, and because a lot of hacks from all different aspects. As I mentioned, we have a lot of conversation with scientists in CSIRO as well. So definitely we need a combination, and we need a combination not only from different government, university, and R&D institute and industry, but we also need a different multidisciplinary expertise working together to move faster to the market.
Thank you. And Tuan, I'd like to go to you next. With all of the advances in automation and robotics and particularly prefabricated construction, what do you think Australia has the opportunity to do that's really unique?
Thank you, Bronwyn. Actually, we discussed a lot in the industry. We have to do more with less, because more is about, if I take construction building industry, we need to build a lot more houses. And our government has committed to 1.2 million homes to be built in the next 5 years. And in Victoria, 800,000 homes in the next 10 years. Currently, we are actually doing only 180,000 homes. So we need to build 60,000 more homes every year over the next so many years. So with a lot more work to be done, not just to mention infrastructure with $120 billion pipeline. So with the current workload, our construction workforce is really at a crisis level, because we have a huge skill and labor shortage. Almost 120,000 workers is needed in the industry, and couldn't get more. And of course, at the same time, we need to build with less waste. 70% of the waste coming from construction, not just to mention the 40% of the emission is coming from our industry. So with more, how we do more? I think advanced manufacturing is the key. We have seen in our industry, we got a lot of innovation. I was involved in the first modular prefab building in Melbourne. It was built 15 years ago. And one building, an apartment, is about 70 apartments, was done in 4 weeks. It typically would take probably 1.5 years. So example like that, we have success stories, but a lot of failures as well. But I think we can learn. I just want to take defense. I think we have done well in some part of the defense, how we can learn from automotive, how we can adopt new Industry 4.0 in construction. That's really the key to me, and I really want to share more, but of course I want to hear from other panels.
Thank you so much. I want to move to translation more specifically, and Baohua, I remember seeing your laser nanoprinter at a very early stage when it was just a proof of concept. How have you thought about scale and how you scale up and translate that technology to industry?
Thank you, Bronwyn. This is a really interesting question. Actually, photonics is a new industry, in particular for this using laser to fabricate nanostructures and then translate them into real application space. This sounds like still a long way to go, but it's actually happening right in Australia. The industry partner we've been working with, they are actually leading in the world in terms of producing this machine as well, all automatic, fully automated intelligent machine to fabricate this very tiny structure. So one of the structure they normally show is some structure fabricated on a human hair. So which is really tiny, it's a Venus. You can fabricate like arbitrary thing, 3-dimensional, into like any substrate you like. And it's not only for fun, it's actually for functional devices. So for example, if you have like microfluidic device, so to do the biomedical test, you can also use that for communication devices and also for this photonic computing. So I think one of the key advantages of Australia doing advanced manufacturing is really this innovation. So as a nation, I think also a little bit of follow-up of Steve's slides. So if we look into the space, manufacturing space, I think it's changed really rapidly. As a physicist, we always tell us, uncertainty is the only certain thing we know about this world. So it's happening every day. So basically this changing is happening all the time. Just recently, especially after COVID, the pace is actually getting faster. Previously, the industry sector, like for changes, it may take decades, but now it's overnight. So within such a kind of circumstance, I actually see there is a huge opportunity for Australia industry to take leadership in advanced manufacturing. Because think about that, for conventional manufacture, like labor intensive or facility intensive, it's very difficult for them to shift. But for us in Australia, we dominated by SMEs. So they're innovative, they move faster, they're more agile. And we also are like a nation full of innovations. So we have our Wi-Fi. So CSIRO is actually leading that invention, like flight black box, and also more broadly like Google Maps. So we have all this success, and then we have the past like translation changing the world. I'm pretty excited and confident that by taking this opportunity, seize this opportunity, we have really good opportunity to lead this advanced manufacturing. Thank you.
So much. Chamindie, you have such a unique background in coming from Philips with the commercial pool of technology to having that discovery about a biomarker in saliva and then turning that into a diagnostic test. In the theme of today in breaking barriers, what were the barriers you needed to break to translate that research?
Thanks, Bronwyn. Multiple barriers. And I'll just give you some stats about Australia. I mean, it's very disheartening. We are in the top 95th percentile in innovation. We have the fantastic universities in the top 50 universities in Australia. However, we are in the bottom 5th percentile when it comes to translational and commercialization. Why is it? We have the innovation. Why can't we bring it to the market? The same thing happened with the technology that we developed for about a decade. And I had to work with a company in the US called Biomedical to bring it to the US, to bring it to market in the US with the FDA approval. If I look at why we can't do things in Australia, is it because we've got no money? No, we do have. Australia is one of the richest countries in the world. Yet when it is in the manufacturing space, we are like a third world country. I think there should be some action both from the government side and also the university sector. KPIs for professors, if you look at KPIs for professors and KPIs in industries, they never match. I had to, on multiple occasions, put my publications, we could not publish simply because we had to protect our IP before publication. Yet I have my PhD students, they need to publish. So we are always in that dilemma because the interests don't marry, and that's one of the biggest barriers, is that industry pull or industry KPIs and the university sector KPIs don't marry. So as university professors or university researchers, we have that dilemma. And I think we have a fantastic opportunity because the government has now put $15 billion into the Australian Reconstruction Fund to enhance collaborations between academia and industry. I think we also need a very strong policy underlining that partnership, and there should also be a monitoring system. So to give you an example, if you have company X working with University Y within a, let's say, 5-year time, so what are the new products developed and how they have translated into the community? We as researchers, we are always paid by the taxpayer money. We owe to the taxpayer. We need to do something different than what we have always been doing. So I think we all have a responsibility in the university sector to make it work for Australia, not for us, but for the future generations to come.
Really good point, thank you. Before we move to the audience questions, so have your questions ready. Stephen, the next theme is collaboration. I was really struck by Brian Schmidt's point this morning around how some other nations, and he mentioned the US, are just exceptional at creating purposefully designed research ecosystems. And I know your faculty that you've led and how collaborative it is and how much you've broken barriers between disciplines. What have you learnt from that, and what advice would you give?
Wow, that's interesting, good question. And to pick up on this point that was mentioned here a moment ago, Australia's investing $15 billion The US is investing $1 trillion in the same thing. And if we're not careful, a lot of our good stuff will be simply offshored. So getting to your question, starting with the areas that really go across, right, the big themes, what we would call institutes. So we know that Australia's biggest areas at the moment are around energy, right? This is cross-cutting. It starts right from civil engineering, dealing with the infrastructure that you have to build, the transformation, the grid, through to the chemical engineering and the battery storage, through the mechanical engineering. It covers everything, right? We need to be able to bring not just an institution, UNSW, but all institutions, because we have so much skills locked away and capabilities and equipment and capacity in universities that if we bring to fruition, we could do great things. But we don't have a roadmap to do that. And it has been mentioned here by other panel members and earlier this morning by Vivian and Brian. Universities are good at the first part of the technology roadmap. In Australia, we're extremely conservative and we have the last part, but it has to be an almost near commercial product at that stage. And then we have the valley of death between that. And if we don't not get good in this part, we will just simply see a lot more offshoring of our ideas and our IP. And I think the solar example I said this morning is the perfect example of that, right? In 1990, solar was ramping up. We led that. 90% or 92% of all solar technologies come out of IP from Australian universities. All the patents are long lapsed. We get to 2015 when all of a sudden it's ready and we are not the net beneficiaries of our own IP. So we need to do that and we need to work out that roadmap. And it's not just universities, it's got to be policymakers. And I do get concerned, Bronwyn's point this morning, she was Bronwyn's point this morning, two persons within the government, two engineers in the government department. We need more engineers at the policy making levels. Brian's point about the $5 to $10 billion, that's what we lose on our infrastructure projects which go over cost. So we have the capability, we have the things, we don't have the roadmap to do it.
I was struck by our conversation earlier around the solar car challenge, and you have a team who's currently out there racing in the outback, and how naturally bringing all these different disciplines and systems together comes to that next generation. What do you think we can learn from them? And
they're a fabulous team, and that's my apologies I didn't get here last night because I was out there in Alice Springs with them. But in the educational sector, bringing these experiential learning. So that's a team of 120 students. It's led by an ex-Formula One Red Bull racing director who sort of manages this team. The teams themselves are led by the students, and then there's the academic leads in each department. So we have battery specialists, we have solar specialists, we have people from mechanical engineering look at the aerodynamics of the car, and they are there together in the educational system. We need to move to a much more experiential learning model within universities, but this is expensive. It is. Right? Yes. And we talked also about the mismatch between expectations on academics' KPIs and what we would like in Australia. But it's not related to that. It's related to the fact that our educational sector is financed by international students. And the international students look at rankings. And rankings require you to meet certain KPIs. So it's linked to a much bigger thing than that. How do you fund education in Australia to deliver that experiential learning?
And that's the topic of the University Accord, which we all have the opportunity to contribute to. Are there any questions from the floor?
Sorry, I just apologise to Jane. So.
Yes. Do we have the roving mic?
Thank you, Therese Flapper. I'm interested in the role. We've talked a lot about KPIs. We've talked about that most people know that you do what you measure and what you track. One of the things I'm personally interested in and advocating for is, this is probably a bit specific to Professor Tuan amongst a broad range of professors we can choose from, but then going beyond it, in the construction industry and the built environment, for me we have every single opportunity for government and the private sector to just mandate that embodied carbon and scope 3 must be measured from design all the way through. We've got the tools. Okay, they're more iPhone 5 level maybe, not the iPhone 14, but if we don't get started, we'll never get to the iPhone 14. So would you advocate and think we're ready for embodied carbon to be one of those KPIs? And then what are the other KPIs? If ATSE put a position paper out on what KPIs we should do to bring all those triangles together around industry and research, what would they be?
Thank you very much for the question. And of course, this is something I'm really passionate about, because as we know, with our building and construction, the carbon footprint is really 40%. And at the moment, of course, it's probably a lot more in operational energy and embodied carbon. But very soon, because we can do well in that renewable energy, when the embodied carbon in our material is getting really a significant portion, and predicted to be about 70–80% mixed in the very near future. So we really need to mandate that, how we can track embodied carbon in all the material we are using in the system we are going to use. So actually, very recently, we got a really good funding from the Department of Energy and Climate Change to set up a research network for decarbonizing the building and construction industry. So with that, we are going to develop roadmaps and identify all different material, key material coming from either cement, concrete, steel, timber, and really come up with a system how we can track it down throughout the whole supply chain. It's also one of the focus about CRC. We are looking at using new digital technology and working with companies like BlueScope to come up with a systematic methodology and also a technology to really embed that in the construction processes, from design to construct to even operation and end of life. So if we can do that, I think we can really have a lot of information, but it's going to take time. I just want to mention again, because of the CBAM, the carbon body adjustment mechanism is coming. And if we don't have that framework, and the platform, really hard to track it down. And I think our colleagues, I think Steve probably in our construction, we really have to deal with that up front, because Europe is already starting this from this October. And of course, in 2 years' time, everything coming from outside Europe, that would be basically taxed. And of course, our government is doing, hopefully we follow a very similar approach. So we need to do that very quickly.
It is absolutely coming, and very quickly I've become aware that there's been some rapid advancements in the digitalisation of carbon footprint accounting. Yun, I just want to come back to you, because you're working on hydrogen storage, and that's been such an important part of our energy transition. What's the carbon footprint of some of those hydrogen storage technologies? How environmentally friendly are the materials that we're using to store hydrogen?
Okay, so that's actually there's a lot of people talking about the hydrogen. Like hydrogen storage, we will try to using definitely you need to have some green sustainable. That's very critical and for the future. So the technique we developed, actually you can use in the organic carrier. People talking a lot about the safety issues about hydrogens, because you deal with the hydrogen molecule. So once you bonding the hydrogens and in the materials, like for example, water has two, like H2O have two hydrogens. So in that case, you can bonding the hydrogen more solid, and so you can actually create this closed loop. The hydrogen storage technique, you don't release any hydrogen. Pretty much you take this as a black box, so hydrogen and hydrogen out. You don't have anything to affect the environment and something like that. So that's actually is grateful. We need to consider to move forward to the market.
Thank you. We have run out of time. It's just absolutely flown. It's been such a joy speaking to you all. I would love to hear just one last comment from you about if there's one barrier we could break, what would that be? Starting with you, Baohua.
Yeah, I would like to say translate innovation to real technology. That's where the gap is. So we have so good innovation happening in the research field. So if we could contribute as a member in that to try to meet that gap and then help to make translation more successful, that'd be really, really great. That's my passion. Thank you.
Thanks, Baohua. Stephen?
And I'm just going to go to that last question on legislation or on things. Please push that. It will make my job so much easier, right? I looked it up in the dictionary. Engineers defined as private and conservative. I looked it true up in the dictionary. Until we get our ability to move standards, which are a roadblock, right? To develop new materials, to take into a carbon accounting at the time of design, you'll end up just being like, and if even it's not going to legislation, at least the big government building authorities, the transport infrastructure use so much of our products, if they could lead by example, right, by saying this is how we're going to do it, it will push everyone or pull everyone along, and maybe we can get alternative binder into concrete and account for all our carbon prints. So,
thank you. Yun?
Yeah, I think because we are talking a lot of technology transfer for the startup and build the new manufacturing and create our innovative industry. But I think if I want to say if government can support the education training to prepare our people to ready for the to get new skills to come to the professional field market. That's very important.
Thank you. Chamindie.
I think we need to increase the nexus between industry, academia, and government. And from university sector, the KPIs for researchers and KPIs from industry, they need to really match. And we also have a duty from the university sector to educate our next generation and bear in mind that they are very heavy tech. How do we take these heavy tech students and give them equip them for the 21st century, because most teachers or lecturers are not from the 21st century. So we also have that we need to bridge the gap in the, how would I say, technological advancement. And I think if we have proper policies, I keep going back, I'm not a policy maker, but I think it's really important from a government perspective to have policies to increase commercialization and translation. And we also as Australians, we need to be taking risk. We need to fail. And we need to fail fast, and we need to learn from our failures and move on, not badger person, just because you did a startup and you failed and now we won't invest any money on you, so you literally your career is gone. No, risk. So I'm Dutch and we are taking risk all the time. I had 2 PhD students when I was in Netherlands, and both of them did startups. Startups got acquired, they've gone to the 2nd and the 3rd startup. I think we can do it in Australia and we should be able to do this.
I'm dying to hear from Tuan.
Yes, just going back to my previous point, we have a national housing crisis. And to me, fundamentally, we have a productivity problem. We need to crack that. And to do that, we have to have a better model for collaboration. So the key to me, how we can collaborate, we need multiple platforms to collaborate from government to industry to academics. So ATSE is really the excellent platform. That's why I'm very passionate and really excited to be part of it. We can make it happen. Thank you.
Fascinating discussion. Let's thank our panel.
And thank you too, Bronwyn. Thank you to Baohua, Stephen, Yun, Chamindie and Tuan. That was a terrific conversation and one very dear to my heart, and I think a resounding endorsement of our 3 key policy priorities here at ATSE. That is addressing climate change through mitigation and adaptation. Supporting a thriving ecosystem that supports the application of terrific Australian R&D. And of course, educating and inspiring young people with the skills and the opportunities to both enter and to thrive in science, technology, engineering and mathematics. And I'm delighted to hear the passions of new fellows, because it is only through and with fellows' work that the Academy is able to pursue that important role in providing expert advice to policymakers as well as other decision makers across the breadth of Australian leadership. I also call on fellows, both new and ongoing, to think about how you can support our programs, because we do have very structurally specific ways to address some of the problems that we spend a lot of time advocating for policy change to address as well. So we do have a secondary school education program, Stellar, which is bringing engineering, mathematics and science to life in Australian secondary school classrooms across the nation. We have a scholarships program to support Australian women and non-binary people to enter and thrive in STEM degrees, both undergraduate, postgraduate and at the leadership level. And we have an industry mentoring network in STEM. And through all 3 of these programs, we are supporting and nurturing diverse people to enter, acquire the skills in STEM and, of course, the opportunities and the support to thrive in those careers. So please do consider getting involved and supporting those, either as assessors, as mentors, as even just as champions and advocates for the work that we're doing in your own communities and networks.